waves in a large free sphere of water. Here we have a large free sphere of water about the size of my head, 130 millimeters in diameter, and we put a puff of air, 10 cc's in 100 milliseconds, radially directed in from the side, and look at the resulting waves. And there's a combination of surface waves and body waves that go through this sphere. We saw that in real time. Now we see it in slow motion. Starts off with a crater sending a droplet off, and then a series of surface waves which come together at the antipoidal or 180 degree point from the impact, and these waves collapse back down and go across the other side towards the impact point, and they continue until viscous forces dampen things down. A delightful interplay of both surface and body waves here. Water droplets in a bubble in a sphere. Here we have a sphere of water, 75 millimeters in diameter, with an air bubble inside, about 35 millimeters in diameter, and we inject water droplets anywhere from 1 to 8 millimeters in diameter into the bubble and look at the resulting collision dynamics where they collide with each other and the walls. Most of the collisions result in an elastic collision, but every once in a while a collision will result in a mass transfer across the interface, and this mass transfer has a momentum exchange associated with it which will propel the droplets. Here a droplet is going in circular motion on the inside of the sphere until a mass transfer occurs and propels it off the surface. Effervescent antacid tablet in a water sphere. Here's a sphere of water 50 millimeters in diameter with an effervescent antacid tablet. Bubbles form rapidly from a chemical reaction. This is an example of heterogeneous nucleation where bubbles form on a solid surface and can get a momentum exchange and travel out into the fluid. The bubbles rapidly coalesce. Once they reach a certain size, they seem to eat other bubbles at a faster rate, thus growing larger. And in this form